Hi everyone, welcome to our Intro to Firebase talk today. Hope you've all been having a good time at the hackathon so far. My name is Andrea, and I'm a software engineer at Google on Firebase in our New York City office. This is our agenda for today. I'm going to briefly introduce Firebase by letting you know what it can do at a high level, and then we'll chat about how and which Firebase products might be helpful for your app during the hackathon. We'll also step through an example app to show how these products can be used together. And so we ask, what is Firebase? Firebase is Google's app development platform. It's based on Google Cloud Platform, and Firebase integrates with several other Google tools, such as Analytics and Ads. And of course, it's built on Google infrastructure, so it's designed to scale. Firebase products support a lot of different client app platforms shown here. We have client-side SDKs for iOS, Swift, and Objective-C, Android, Java, and Kotlin, Web JavaScript, C++ and Unity for game developers, Flutter, and several popular frameworks like Angular and React Native. We have a series of server-side SDKs as well to plug into your existing backends. Firebase is a suite of almost 20 products, and these are the categories we like to think about to make sense of all of Firebase's product offerings. Firebase is intended to help you through the life cycle of developing apps, which typically goes something like this. When you're first starting out, well, you'll need to build the app. These are the products that can help you do that. There's authentication, which is a logging in system, Cloud Firestore, and real-time database, which are both NoSQL databases. Cloud storage to help you store big blobs of data like photos, videos, and audio content, and hosting, which helps you put your website onto the internet. After your app is built and deployed, you can monitor how it's doing in terms of performance by using Crashlytics and performance monitoring, and you can fix any quality bugs and use TestLab to test those fixes on different devices. Once that's done, your app will probably reach a stable state, and you may want to grow your app to attract more users as well as retain the users you already have. Since we're at a hackathon and there's a super short amount of time to actually build a product, we probably won't get to the stage of improving app quality nor growing the app. If your team does decide to continue on with the app after the hackathon, though, the improve and grow products could be really helpful. All right, so now that we sort of know what Firebase is, let's talk about using it to build out a new app. Before we do that, let's introduce what we're trying to do. We're going to build an expense tracker. As a person who really cares about how I'm spending my money, I really want to keep track of my expenses. What I actually do now is keep a spreadsheet of my expenses. I look at my receipt and manually enter the date, vendor, item bought, and amount spent each time I spend money. And this is fine until this happens. Having tons of expenses because I procrastinated and let my expenses pile up, or I went on a business trip and have a ton of expenses from all those lifts I took and each delicious meal I had at all those amazing restaurants, on top of the flights and hotel expenses. It becomes quite painful and tedious to manually enter all of this data. In large quantities, it's just really not that great of an experience to have to manually input the date, the vendor, the item bought, and amount for all of those receipts. Since we're now at a hackathon, why not make an app to make this all better? Instead of having to manually type in expense data for all of those receipts that I'm keeping around anyway, let's make an app to allow users to conveniently scan receipts, and the app will automatically extract the relevant information from those receipts. That way, the app does all the work with just an uploaded receipt image, and it can send extracted information to the user for verification. The user no longer needs to do any manual work other than taking a picture of the receipt. So what are our app requirements going to be? Well, first, users will be able to upload images, either by taking a photo through their camera or by choosing an image they already have on their phone. Then, our app needs to find and extract the text. We'll want to scan the receipt to parse for things like the date, the vendor, item bought, and amount spent. Finally, we'll relay what we found back to the user because we need them to confirm the information we extracted. Hopefully, we did a good job with the scanning and it's accurate. If we did a bad job, then this isn't much of a confirmation step anymore since it'll become a correction step. Since the whole point of building this app is to make it easier for users to just upload their receipts and not have to manually input information, it'd be pretty bad if the scanning was bad and we eventually made the user input information anyway. Diving deeper into what we want our app to look like, these are some of the needs. We want to be able to securely upload our receipt images, store these receipt images and extract the text, and do some image processing on the uploaded receipts. This sounds a little bit complicated, but let's see how we can do it. The first thing we said we need is secure image upload, which means we need users to be able to sign in. I don't really want to spend my precious hackathon hours building a logging in system, and it'd probably be quite tricky to get the security of it correct on the first try. Also, as a user of many apps myself, I know that I don't really enjoy creating a new account for every single app that I use. It gets pretty repetitive to set up an account with my first name, last name, email, birthday, the name of the street I grew up on, and so on. Then I have to remember my password, which I probably won't be able to do since, well, we're supposedly using different passwords for all of the millions of accounts that we each have. It'd be really nice to not need to create a new account to use this app. Well, we have Firebase authentication. Auth provides identity as a service, meaning it lets you know who your user is. It also provides a rules system that lets you grant or deny access to resources in other Firebase products like Firestore and Storage. Auth also is ready to use out of the box, and it gives some advanced functionalities like email verification and account linking. Regarding the concern about not wanting to create a new account, Firebase Auth works with many third-party identity providers, including Google, Facebook, Twitter, Microsoft, Yahoo, and more. Once users sign in with one of these services, we assign that user a record within Firebase's system. This includes a unique user ID and a signed web token, so you get a consistent representation of your users, and one that you can use against both Firebase's services and your own custom servers, no matter how they sign in. Let's take a look at what the code will look like if we wanted to allow our users to sign in with Google. Assuming we already created a Firebase project and injected the correct Firebase dependencies, we can handle authentication with very few lines of code. Also, don't worry about copying this code down. It's all in the Firebase documentation, as is all the code being used in this presentation today. First, as shown here already on the screen, we'll need to create an instance of the Google Provider object, which says we want to use Google to sign in. If you wanted to use Facebook, Twitter, GitHub, and so on, you would use those respective providers here. Next, let's actually make the user authenticate. There's two ways to do this, either by opening a pop-up window or by redirecting to the sign-in page. What's shown here is signing in with pop-up, and we pass in the provider into that function call. What this says is use Firebase Auth to sign in with a pop-up using the Google provider. Finally, we handle the cases of a user being successfully signed in versus not. So this is how we could implement authentication using our third-party providers with just a few lines of code. Let's say we did want to give users the option to create an account using usernames and passwords. Firebase authentication can do that too, and it'll securely store and encrypt this information while also taking care of necessary tasks like generating password reset emails when your users forget their password. If you don't want to force users to memorize yet another email and password, and they don't want to sign in with any of the third-party providers, Firebase Auth has support for phone number authentication, which allows your users to sign in simply by receiving a code through a text message. Let's say how we'd be able to make a user create an account with email and password, as well as how to check whether a user has already logged into the app. To create a user with email and password, we'd have to first make some pages for the user to create an account as shown here. Assuming the users fill in both username and password, then we can use Firebase authentication code to create an account. Calling the create user with email and password function while passing in a typed-in email and password from the screens before will result in either a successful creation of the account or it'll fail. If it fails, we can handle the errors here. If it succeeds, we'll be able to see the user's new account in Firebase Console. Let me show you what that looks like. Firebase Console is a web portal to let you see what you've been doing with Firebase for your project. So in this case, we'll be able to see all of the users who have logged into your app, as well as their email information if they created an account on your app. So let's go over to the console. If we go into authentication, we'll be able to see all the users who have signed up with their email or any of the providers for your app, and we can see their unique user ID. Now, let's pretend the user had to log in again, and they already have an account and wants to sign in. This, perhaps, is the screen for it. Upon pushing that submit button, we'll call the sign in with email and password function and pass in the email and password from the screen before, and this will result in either a successful sign in or it'll fail. If it fails, we can handle the errors here. Now, let's talk about the succeeding case in code for both creating a brand new account and signing in. To get the currently signed in user, we set an observer on the auth object. Anytime the authentication state changes, this function will get triggered, and if there's a user, then the user is signed in. Otherwise, no user is signed in. This function will return a user whenever create user with email and password and sign in with email and password get called successfully, as well as with third-party providers such as Google, Facebook, Twitter, and so on. Once you have the user, you can also get various information about the user, like display name, email, and their user ID as shown here. So now we've seen how to write just a few lines of code to sign in, create an account, and check if a user is already logged in. Sounds much easier than trying to write your own authentication system, right? One last tidbit. Even though the code is already not much thanks to Firebase Auth for all of those steps, it's quite a bit of work to actually make these a sign-in screen. Sign-in screens with multiple third-party sign-in buttons, or a create new user screen, or screens to reset and change passwords. And if that's not where you want to spend your development time, you can use the Firebase UI library, which handles all of these cases for you. It's an open source library, so you can customize it as you'd like to fit the look and feel of your app. So now that we've allowed users to sign in through some of these third-party identity providers or through creating an account, and we know whether they're signed in or not, let's move on to our next step, uploading receipts. Let's say we have a screen to allow the user to upload the receipt, either by taking a photo of it or by choosing a file that already exists. Once they do that and upload it, we should store these somewhere. What do we need from our storage system? Well, we like it to be fast for uploading and viewing receipts from anywhere. We want it to work well even with spotty internet connections. And we might need to store a lot of receipts, and we don't have a bunch of people to keep an eye on usage and adjust our storage capacity. Lastly, we may have to consider working with a variety of image types. Luckily, cloud storage was designed with many of these concerns in mind. It lets you store many types of image types, and on top of that, it lets you store and serve user-generated content like audio and video. It's generally used for storing big blobs of data that you don't need to change very often. To store a lot of receipts, the amount of storage will scale automatically, meaning that storage space will increase as you have more content, and it'll decrease as you delete content. You won't need someone sitting there manually managing the amount of space your app is taking up in storage. To be fast from anywhere around the world, cloud storage has a global edge cache, which means that if I just pulled up a receipt to look at it, storage will store that in a nearby cache. So if I want to see the same receipt again 5 minutes later, I'll be able to get that receipt image quite quickly. Sometimes, like I was saying before, internet connection isn't so great. We want my receipt to be half uploaded and then dropped because my internet was spotty. Luckily, storage takes care of this and handles retrying and resuming my uploads and syncs whenever my phone gets back its internet. After my receipt is uploaded, it can be shared with other users instantly. So this means that if my parents want to look at my receipts for whatever reason, they can look at them right after I upload it. But I don't want to just let anyone be able to see my receipts. There are security rules I can set to protect it, using auth that we talked about earlier. The rules can say who is allowed to read and write certain files in cloud storage. Now, let's look at some code to upload files. Let's say we have a file we want to upload. Firebase Storage supports files from JavaScript file and blob APIs, bytes, strings, base64 formatted strings, base64 URLs, and data URL strings. Where are we going to store it? Let's grab our storage bucket and create a root reference. And from there, we can create a child reference to the full path of the file with the file name. Now, with our reference, we can then upload it to cloud storage by calling the put method on the reference. The file will then get uploaded, and we can do any post-processing needed after it does so. In our case with the expense tracker, we'd get the file selected by the user using the JavaScript file API, and upload it according to storage using this code. So now we've uploaded our receipts into storage. Next, we'll probably want to run some code to process the receipt. But we may not want to do all of the processing on the client side, which would be a phone. Why not? Well, once we write our top secret code to process those receipts, we don't want anyone to just be able to take it along with the data. Requests coming in from users' phones might be trying to steal it, so we need something to help us with running code against our data securely. We want both iOS and Android users to be able to use our app, but we may not want to duplicate code to process the receipts twice. It'd be much better if we could write it once and have the code run, instead of writing it once for iOS and deploying to the App Store, and writing it once for Android to deploy to the Play Store. Also, if we deploy the app separately, iOS users may get this awesome feature first, and Android users might get mad. We definitely don't want that. And remember, we're looking to process our receipts. We mentioned we'll need to run text recognition on the receipts, which we can imagine might be CPU intensive. The last thing we want is to run highly intensive code off of our users' devices, especially if it might drain a user's battery. Cloud Functions can let you run code in the cloud. It's in a secure environment, and you can write it once for both iOS and Android. To run the code, you can trigger it based on platform events or a HTTP request on both platforms. And since it's running on the cloud off of the user's device, this won't be hard on their devices. Best of all, you can basically run backend code without managing any servers. We know we're going to use functions to run our processing, but what are our functions actually going to do? Well, we need some machine learning to help us extract the numbers from the receipt, also known as optical character recognition, or OCR. We want this to get automatically done, but I don't really know how to do machine learning. Machine learning is not a trivial task, and usually a team will need a data scientist or a machine learning expert to build and train models. And in order to serve these models dynamically, we'd have to build up the infrastructure to do that. And that's before we even write the client code to interact with the model and generate predictions. This sounds like a really involved and long task, which we don't really have time to deal with at this hackathon. Luckily, we can use machine learning to help us. What is Firebase machine learning? We take some of Google's best machine learning models to help with different machine learning capabilities, depending on what features you're looking to add to your app. It can recognize text or barcodes from an image, translate text to a different language, or identify important objects in a photo. No machine learning experience is needed. Just call these Google Cloud Vision and natural language APIs in your app, and you're basically ready to go. While these libraries can be useful in many situations, what do you do if you have machine learning needs that don't fall into one of these categories? Well, Firebase machine learning has custom model serving and AutoML Vision Edge that makes it easier for you to create and deploy custom machine learning solutions on your users' devices. Which one of these do you think we should use for our OCR? If you guessed text recognition, you're right. So now that we've used some machine learning to extract text from the uploaded receipts, what's next? Well, after we get the text back, we need to put it somewhere in a secure environment. There will probably be a lot of extracted text, and we want this text to be quickly accessed from anywhere in the world. Where should we put it? Cloud Firestore. As a reminder, earlier we talked about storage, which we use to store the receipt images. Storage is usually used to store big chunks of data like images, audio, and video. Cloud Firestore, on the other hand, is a NoSQL database where you can store data like strings, numbers, and whatever your app requires. Firestore is used more for structured data that you might be changing often. So while our receipt images are stored in Firebase storage, the processed text that we get back from Firebase machine learning will be stored in Firestore. Very similar to storage, Firestore integrates with Firebase auth and security rules, so clients can talk to the database directly, but you can still make sure they only get access to the documents they're supposed to see or modify. Let's dive a bit deeper on how Cloud Firestore is structured and how to use it. It's a document model database, which means that all of your data is stored in documents and collections. You can think of a document as something like a dictionary or a hash table. It has a set of key value pairs, which we refer to as fields, and the values here can be a number of different types, anything from strings to numbers to binary values to JSON-y looking objects called maps. So here we have the document containing the fields we saw on the previous slide. Each of these documents is stored in a collection. Documents can't contain other documents, but they can point to collections that contain other documents, which can point to subcollections, and so on. So in our example, each document will contain information from one uploaded receipt. Here are some examples of what that might look like. Each receipt document contains some values, including date, amount, vendor, item, and whether the user has verified these details yet. All of these will go into one collection, a collection for the user. With code, it'll look something like this. First, we'll get our Firestore instance, and then we'll make a collection on it. Since we're making a collection per user, we'll want to identify each user. How should we do that? Well, since we used Firebase auth earlier, and that returns a token that uniquely identifies each user, we can just use that as the name to identify each user's collection. To create a document, we'll need to use the add method. What are we adding? Well, we want to add the key value pairs that we see in this receipt. When the document is successfully added, we can do something with that. And when there's an error, we can handle it as well. Let's see what this looks like in Firebase Firestore in the console. So on the left here, we'll go to Firestore database. As you can see here, here's a token from authentication. And the document name is a random string made up by Firestore. I didn't type that in anywhere, and that automatically happens when we call add. I'll talk about a case where we might want to actually name each document in a moment. Inside this document, you can see all of the fields that we added: the amount, the date, the item, the vendor, and whether the user has verified this information. Now that we've added the extracted text for our expense tracking app into our database, how do we get that data out of the database in order to send to the user to ask them to verify the amount? We're going to use the get function to get all of the documents within our collection. We then loop through each of the documents and send the information to the user to verify. All right, so now, as I mentioned before, we didn't really care about what each document was called, so we let Firebase set a random string for each receipt document. Let's pretend for a moment that instead of tracking each receipt, we are using this app to track an entire family's expenses. We want to track the total cost the family has spent in the year, but we don't care about each specific receipt amount. In this case, we'll create a collection of total costs, and each document will be for each family member containing information about when they last spent and the total amount they've spent this year. So like before, we'll make a db.collection, but this time with name cost. We'll also have a doc for each family member who is using this app, so each family member will have their own unique auth token. We can then set the document to be identified with that unique auth token. And then we'll use the set function, which pretty much does the same thing as the add function we used before, except that it uses the specified name you put in here. And like before, when the document is successfully added or edited, we can do something with that. And when there's an error, we can handle it as well. In Firebase Firestore, this is what it looks like. So we have our cost collection, and inside of our cost collection, there are 3 different documents, one for me, one for dad, one for mom. And inside each of these documents, we can see the amounts, we can see the data that we added for each one. Let's see how to get that amount. Like before, we'll find the cost collection and the doc with my auth token. We'll use the get function just like last time, but instead of getting all of the documents, we'll only have to get that one particular document for one particular family member since we specified the document. If getting it is successful and doesn't error, we first check whether the doc exists and pass that data along if so. If not, we'll log that there's no document. If getting the document errors, then we'll log it as such. As a side note, in Firebase, we actually have 2 database products. One is Cloud Firestore, which we just talked about, and the other is Real-Time Database, which is the older database product. Cloud Firestore is generally a better option unless you need to structure your data in a JSON tree instead, which is typically better for structuring your data from your views. The link here describes more differences between the two, but if you're not sure, pick Cloud Firestore. Now that we have extracted text by deploying functions that runs our text recognition and machine learning, and finally stores in Firestore, what comes next? We want to notify our users that we have their values, and we'll ask them to confirm. How do we do that? Let's send a push notification by using Firebase Cloud Messaging to tell users to confirm their receipts. Firebase Cloud Messaging is a powerful and scalable tool, and it can deliver hundreds of billions of messages per day, with most of them getting delivered in less than 200 milliseconds. Our users trying to upload receipts probably all use different types of phones. Thankfully, we don't have to invent our own notification system for each phone because cloud messaging can deliver notifications to anyone using Android, iOS, and the web. Cloud messaging doesn't need us to track what kind of devices our users are using, and we also don't need to set up different service calls to different devices. Firebase will automatically do all of that for us. Lastly, we're not only limited to using this to remind users to confirm their receipt amounts, we can also announce new features we're launching. For other apps that isn't this expense tracker, we can notify users for things like letting them know their last message was responded to, sending out discount offers, and reminders about events. So now we have notified our user to confirm their receipt amount. We'll store this response back into Firestore. Now that we've built our app, it's just sitting on our laptop or perhaps in GitHub. If we built this using mobile, like Android or iOS, which is most likely chosen platform for this particular app, we'd eventually figure out how to put it on the Play Store or the App Store. If we built this on the web, we can use Firebase Hosting to help us get it off our laptop and actually deploy it onto a website for people to use. So let's talk a bit about Firebase Hosting. First and foremost, it's a really easy way to host your web apps. All you have to do is install the Firebase command line tool and write a single command, Firebase deploy. From there, Firebase Hosting provisions a HTTPS certification, which guarantees security and deploys your assets to an origin server that will serve your content through a global CDN. If for any case you want to roll back your app, you can go into Firebase console and roll back from there with just one click of a button as well. Firebase Hosting has global CDN, which stands for Content Distributed Network. And this means that there's a distributed set of servers holding your content. So whenever someone pulls up your page, the content is retrieved from a location as close to the user as possible. For example, if we didn't have a global CDN and only had one server in the US, someone halfway across the world trying to access our website might have to wait a bit for the page to load, which isn't a great experience. With a global CDN, we have another server closer to the user, so accessing our website will be faster because the place to get the content from is physically closer. Sometimes we'll have to update our website after having deployed it once before, whether it's because we changed some content, added some features, or some other reason. When we do this update and redeploy to Firebase Hosting, it's atomic, meaning all of the servers get updated with our new website and all the caches get purged. This way, the user is guaranteed to get the latest version. Lastly, the heart of Firebase Hosting is static, which means you're not using a backend system with your code, and typically means pure front-end JavaScript, HTML, CSS, or any of the front-end frameworks like Angular, React, and Vue. If you're using frameworks like Django or Node, then your app is dynamic. For dynamic sites, we'll combine Firebase Hosting with Cloud Functions to run our backend code and generate content on the server. When a user makes a request to our hosting URL, we can proxy it to our Cloud Functions along with all the request information. Cloud Functions can then do whatever processing it needs to do, grab assets from storage and data from Firestore, and then return all the information back to hosting in HTML. Hosting can then serve it back to the user. Or, if you don't want to use Cloud Functions with hosting for dynamic sites, you can use one of Google Cloud's products called Google App Engine to host dynamic sites. So there we have it. Our app is built. We've successfully built an app from beginning to end with full functionality. We allow users to log in via authentication, upload receipt images which get stored in storage, trigger functions to do OCR using Firebase machine learning to extract details from the receipts, which then get stored in our Firestore database. Next, we run some functions based on values being written to Firestore to automatically send a cloud message to a user to have them confirm their receipt amount. We even put it up on a website so people can start using it. We didn't have to write very much code to accomplish all of this, yet here we are. These are all pretty much the Firebase products that can help you build an app. And actually, cloud messaging is typically used to help grow your app, so I tossed that in as a bonus. Yay! Here are some resources for the materials I covered today. The first one is a link to our Firebase website, and there you can see an overview of all of our products in detail. Each product has a lot of documentation and guides you through that particular product. All of the code I showed you today is on our documentation somewhere. The second link here is our official Firebase YouTube channel, where we show and step you through different Firebase use cases and help you with specific products. Lastly, you can always use your favorite search engine to find more information about Firebase, as it's a pretty well-supported community. Thanks for attending, and happy hacking!